4.4 number 5. There's a sketch. It says the figure shows a rectangular inscribed in an isosceles right triangle whose hypotenuse is 2 units long. So if it's 2 units long, that makes sense. That's 1. That's 1. So if it's an isosceles right triangle, we already know, well, so that's 90. So then this one would be 45, and that's 45 because it's isosceles. The base angles are the same. Alright, so A says express the y coordinate of P in terms of x. Okay, so P is right here, x comma what? So we can find the point along that line would be x comma whatever the line is. So the fact that this is a 45, 45, 90 triangle right here, that means if we went over 1, we went up 1. So this ordered pair B is 0, 1. So that's 1. Go down 1, 1. And the y-intercept is 1. So the equation of this line is y equals negative 1x plus 1. That's the equation of that line. So any point on that line is always x comma negative x plus 1. So we can put negative x plus 1 as the y value right there. Okay, so B, express the area of the rectangle in terms of x, and then C, what's the largest area the rectangle can have, and what are its dimensions. We're trying to find the maximum area of this rectangle. This problem kind of breaks it down into 3 parts. Finding the x comma y right here, then write this in terms of the area of that in terms of x, and then finding the maximum area. Okay, so the area of this rectangle, if this is x, then this would also be x. So the whole bottom is 2x. So the area would be base times height, so 2x times, this height is y for right there. The y is negative x plus 1. So a of x equals negative 2x squared plus 2x. So we have our equation for the area of that rectangle. That's the hard part. Now we want to find the maximum area, find the derivative, set it equal to 0. So x equals 1/2. Alright, so that's the x value. It looks like I drew it to scale. So x is 1/2 in between 0 and 1. That's going to find the maximum area. I know it's a maximum because I could find the second derivative, and that's negative 4, which means a of x is always concave down because the second derivative is always negative 4. No matter where you go, the concavity is down because it's a negative second derivative. Well, we know that because it's a parabola that opens down, negative 2x squared. So what we found here is the x value, the vertex of that parabola, which is going to produce a maximum. Okay, so our maximum area, we could find a of 1/2, and we get 2 times 1/2 times negative 1/2 plus 1. So that's, what's that, 1/2? 1 times 1/2 is 1/2. So our area would be 1/2 units squared.